All right, let's talk about the history of how computers developed a uniform system of encoding all the characters of all languages in written form. And we'll start with the first part in this video about ASCII. Before we start, we need to remember and think about the fact that for a computer, everything ultimately is numbers. And particularly everything, all information is represented as binary numbers, ones and zeros, right? And a unit of either a zero or one is called a bit, which we can think of as a character in an alphabet. But usually we talk in terms of bytes, which is 8 bits. So something like parallel to a word. A basic unit, not the most basic, but the basic unit that we talk about and use the most. So with that in mind, and I've given you a little hint there with part of the chart of how the binary system works, how many different characters can we represent with a single byte? With the assumption that every character needs a unique number. So every unique number in that byte will represent one single individual character in a writing system. With one single byte, how many different characters can we represent? Well, if you did the calculations there, remembered how binary numbering system works, you would come up with a total of 256 characters. Now, think about this for a second. If you have a byte with the maximum number, which would be 8 ones in a row, that's equivalent to the number 255, written 255 in the decimal system. So how do we go, where'd that extra character come from? How do we go from 255 to 256? Remember that we're talking about information, not counting value of something or a total of something. And so in that sense, we have to include the zero. The zero represents information. So there's 256 possible characters with the zero also representing one of the characters. So with a single byte, we can, if you did the calculations, we can store every single letter used in English. And for the computer, both uppercase and lowercase are totally different things, but that's okay because if you add 26 uppercase plus 26 lowercase, we're still at 52, which is significantly lower than 256. So we can store all characters in English, and there's plenty left over for things like commas, periods, spaces between words, which, by the way, is a character. It is a piece of information that has to be represented by a unique number in the computer. Percent signs, even information like backspacing and where a new line begins. All of these things are represented as characters or numbers ultimately in the computer. So there's plenty of room for that. In fact, there's so much that we really don't need the whole byte. Um, and indeed, the first kind of standard encoding system for written characters in a computer only used 7 bits, and that was ASCII. It's pronounced ASCII. It's the most common thing you'll hear is just ASCII. What ASCII stands for, ASCII, is the American Standard Code for Information Interchange. Very fancy name. It's a 7-bit code, so they only use 7 bits, not quite 1 byte to represent all the characters. And I'll tell you just a bit where that extra bit, what happened to the 8th bit in the byte. And it was designed for English text, specifically American English, because there are some characters that British English uses, not real often, but it does appear. So it's specifically designed for an American English. And if you do the calculations, 7 bits can represent 128 possible unique characters. Now, it's still plenty for all the characters in the English alphabet, lowercase and uppercase, all the punctuation, and some left over for things like new line and space, etc. Um, they were able to build this off of a 5-bit telegraph code. It goes way back to the age of telegraph in the 19th century, which actually, think about it, telegraph is not that much different from a computer. Computer has transistors, which is electronic um, element that is either on or off, and just like in the same way, telegraph is usually one wire of an electrical wire that is either on or off. The difference being that, generally speaking, you could hold the wire. You could hold the wire down and have it on, long or short, and that was also used for information. If you know Morse code, you know how that works. But if you wanted to go really fast, you didn't necessarily you didn't necessarily want to take up the extra time to do long or short. So there's other systems they could use, including an on-off system, went very quickly. So a 5-bit, so 5 on and off, give you a number, tells you what the characters are. So they built off of this very old system, added a couple of bits. Um, and again, the 8-bit byte came from the storage limit of early computers. So that was kind of their maximum. So they got it into 7 bits. And this standard was established by the American National Standards Institute in 1963. So fairly early on in the history of computers. By 1968, 5 years later, all computers in the used or owned by the federal government in the United States had to support ASCII. They had to use that encoding standard. And it was used for quite a bit. It was updated and modified as people, needed to use it for different things, and they realized some things weren't working as well as others. But the last time they ever needed to update it or ever chose to update it was in 1986. Um, and from 19, well, whenever the internet came along until 2012, ASCII was the most common default coding on the internet. So something happened in 2012 that became more commonly used than ASCII, but up to that time, it was like the going standard. Now, a quick kind of side trail here a little bit about that 8th bit. What happened to that 8 bits? If ASCII only requires 7 bits and only 128 possible characters, what happened to the 8th one? Well, one of the reasons it was chose to do 7 bits instead of 8 was this was what was used for email. And 7 bits allowed with that limit of 1 byte, 8 bytes, 7 bits was the maximum data, minimized transmission costs. So kept the amount of data that had to be transferred, or so they didn't go beyond 1 byte, but it allowed for maximum data within that. But it left an extra bit instead of, well, without going into detail, basically it left that extra bit to do something that was about giving instructions to the computer, right? So we talk about just static information of a number, it represents information, it represents a character. But when you're working with computers, everything is these bits, everything is on and off microtransistors. You have to have some of them reserved to give instructions about how to deal with and how to distinguish between, okay, these bits here are going to be used to represent characters, but these bits here will be used for programming something else. So you have to give the instructions. And so that 8th bit was kept for the instruction. And it told the computer that might be receiving the email, for example, okay, here's the information about what character set, what encoding standard is going to be used in this message. And that kind of information, the information about the information you're receiving, is called meta information. Meta means in between. So it's the information about the information. It's the information between the information. It's used a lot in computers. You can also think of it as instructions for the computer, so the computer can process it correctly. So that's what happened to the 8th bit. And if you still today kind of root around in your email and dig around in some of the information that's being passed around across the internet, you'll see something called, well, it's multi-purpose internet mail extension. You'll just see it written as MIME. And that is the thing that is providing the meta information about how to, right, for your computer receiving the email, how to process it correctly. So it will tell you which version of this MIME is being used. And within there, you'll see what character set is being used, and then whether or not that character set was altered, and if so, how. So you can see a copy of that down there in the bottom here. And right, so the MIME version here. But what's interesting for us, right? Well, and here's more information actually. Oh, this is text, this is plain text. Okay, so you're going to get text. So there's information about how to process these bits coming in. And specifically, right here on the lower left, if I get, there we go, the mouse to work, there is the char set or the character set, and it says specifically ASCII, but the US ASCII. So that's the version of ASCII that we're going to be using. So that's what happened to the 8th bit. So in a short explanation, we're still using 1 byte, but you only needed 7 bits, and you only had 7 bits available, so 128 possible characters to represent the writing system. And here's often how it was displayed. So you can see on the left-hand column there in each of, well, you have multiple columns. And in each of those columns, surrounded by the blue boxes, you can see in the leftmost column, you have the representation of the number in decimal in blue ink. In the middle, you have the hexadecimal representation of the same number in red, and then you have the character that that number was encoded as in ASCII. And it's usually represented in arranged in this kind of table here, which I'll show you why in just a second. It's really nice arrangement. But just let's start at the beginning here. So the first piece of information, 0, was used to represent a null. And it went all the way over here to 127, right? So 127 plus 0 is 128 possible characters, and 127 actually represented the delete character. So there's a lot of other instructions here, particularly these control characters over here in the first column. They kind of all get kept here. You can see things like line feed, which says, give me a new line, represent a start of a new line, and other things that I don't even understand. So that was the first column, 1 through 31, which is 3-1 in decimal, 1F in hexadecimal. And the second column, you had symbols and numbers. So you had a lot of punctuation. You started with the white space character represented as 32 in the computer. And you had here 0 through 9 digits represented, interestingly, not by 0 through 9 in the binary, but by 48 through 57. And the third kind of layout of this table, we have all the uppercase characters. Remember, uppercase and lowercase, two totally different things to computers. Computers are dumb. To them, there's no connection between capital A and lowercase a. You have to program the connection. So all the capital letters were in this third layout, and in the fourth layout, you see the lowercase. And there's this nice correspondence between the two where you could do some math, and they did this on purpose. And if you added 32 to any of these uppercase numbers, you would get the lowercase version. So it was this correspondence that was kept. So it's nice layout, it's well thought out. If you ever try to sort something by alphabetical order on your computer, and you notice that all the uppercase letters come first, so the uppercase Z comes before the lowercase a, then you will know that whoever programmed the sorting mechanism on that program didn't really bother to take care of telling the computer that capital A and lowercase a are the same thing and should be treated identically as far as ordering, but instead they just use the ASCII table and ordered it by the numbers that those characters represent. So in those numbers, Z is represented by 90, and 90 comes before 97, which is how the lowercase a is represented. So you can see if you ever see that in your computer, and now you'll know what's going on underlyingly and how they programmed that computer. Well, great. This is a nice table. It's very elegant for being dealing with something that's only 128 unique pieces of information. It was well laid out, but I think you probably can already notice, and you may have already asked yourself, well, what about all the other writing systems? What about, I mean, even like I said, there are some characters in British English that we don't use in American English, but they do sometimes. There are, what about, well, what about Chinese and all its characters, however many thousands there are for all the different words? What about the different alphabets? I mean, ASCII's not going to cover that, right? There's a lot more than 128. And if we want our computers to be possible, like the question in this course is, can computers process, store, or handle all ways of, well, in this case, writing, all languages? ASCII's not going to cut it, right? Now, so what did you do back then in the day? Well, there were ways to handle this. So one way was to just take the ASCII system, which was very commonly used across the internet, and everybody kind of knew it and was established very early on, and just extend it. Add some extra letters. So ISO 8859-1, which ISO, by the way, stands for International Standards Organization. So they established this extended system that added extra letters for French and German. It preserved the letters that were the same in those languages, like the A and the B, the S, etc. They would use the same ASCII numbers. They use the same ASCII encoding schema represented by the same numbers, and then they added some more numbers that represented different extra letters that were needed, like the umlaut for French, or the accent mark, or sorry, the umlaut for German and the accent marks for French, for example. And then there was ISO 8859-7, which was the letters that are the same in the Greek alphabet with the Latin alphabet would have the same number. but then you had to have all the extra different letters that the Greek alphabet needs. And how they extended that to Hebrew and Japanese, presumably they use the same punctuation, but probably not any of the same letters because they're very different. I don't know exactly how they did it. So that was one way that you could do it if you wanted to be able to use more than one writing system and go beyond American English. And then there were just other systems that just used something different, or a combination of a ASCII extension plus their own, which led to what really was the Wild West era of the digital age. It was wild. Just give it was yeah, I'll tell you a story in just a second, but just think about this. They're different encodings, extensions of codings are totally different encodings, and so you could receive something on your computer. If you didn't know what coding it was, you know, I mean, if you had the same number representing different characters, which character should I be representing with that number? Or if you had different numbers for the same characters or characters that look the same across the alphabets, which, but that number might also represent a different character in the different encoding schemes. You had to know what encoding scheme was used for the person who typed the message in order for you to be able to decode it on your computer. And you had to have that system installed on your computer in order to encode it or decode it, all the various languages. Um, it was a bit of a hassle. It was quite something. And this was for anybody who was using more than one language with more than one writing system. Um, it really was like the Wild West. So um, long story short, I grew up in Russia. We moved to America or moved back to America when I was in college, and I would get emails from my friends. This was, oh, not that, I mean, it was not that long ago. It was about 2000. The internet was in full force, and they were writing in Russian, so Cyrillic alphabet. It's different from the English alphabet. And sometimes I would get the email and it would read fine. It would display fine. I could read it. But a lot of times I'd get an email and it was just gobbledygook. And I didn't understand anything about encoding and ASCII or anything, but I did figure out, somebody showed me that there's an encoding tab on your email server or on some of the other programs you use. And so if you can't read it, if it's just a mess, then click on that, and you can see there in that top picture that you can see the codes for the different encoding system, but a lot of them would also display the name for the alphabet of the writing system. So I would look for the ones that said Cyrillic, and there was three or four, I think, that would say Cyrillic, and it was a guess. Like narrowed it down to three or four. So I try one. Sometimes it would clear up a little bit, but still be some characters that I couldn't read. I try the next one. Maybe I try the third one and I'd finally get it and it would display correctly. But sometimes I try all three Cyrillic ones and it still wouldn't be readable. And after that, there was this, I don't remember how many, I would say from what I remember, a good couple dozen at least, it seemed like. And so I had no hint at that point. I just had to guess. And sometimes there were times I couldn't read it at all because I just couldn't figure out how to change those characters into something that was readable. It was just weird characters. And this was an everyday occurrence for me, right? This was not something that was like, experts were working with. This was an everyday occurrence for anybody who wanted to be able to use more than one. Or honestly, even if not more than one writing system, you might be using the same writing system, but on a different computer, it just had a different default encoding. So this was an everyday thing that you had to deal with, especially if you didn't speak or read in American English. And I wanted to give you guys an idea of what that was like. And when I looked for it, I realized all of a sudden, oh, there's no way, there's no encoding tab on the email servers. I couldn't find it anywhere. So like, okay, let's go find an extension so we can play around with it. And I found this thing on the App Store, on the Chrome Web Store. And I was like, oh, yes, I remember that. I remember all the list of the different encodings. And I went to download it and I couldn't. So searching around, I found this explanation there, which I've highlighted, that says, due to the low frequency of use, Google Chrome removed the ability to manually set the web page encoding. So yes, wasn't just emails, you'd also do on those web pages. Um, and this, if you look there in the lower right-hand corner, you can see that this extension was last updated at the end of 2020, December 9th, 2020. And so something happened between ASCII being the most common default, and you had this Wild West era, up until 2012. By 2020, or shortly thereafter, the need to use all the different encodings became so low in demand and so even for people that wanted to play around with it, so infrequently used that there's not even an app that you can download to kind of see what that was like. And so something happened. What happened between 2012 and 2020? Well, that's going to be in our next video. For now, what I'll say just that it was a mess, it was a hassle, and so we needed a solution. And to give you a hint of what's coming next, the solution was called Unicode.